Hello, this is Dr. Mears. Today we are going to be going through the mathematical modeling process, and we're going to be developing a linear model using real-world data. So here is the mathematical modeling process that we have reviewed before. In this nice little flow chart here, a real-world problem is posed, we develop a model and test it. If we reject it, we have to go all the way back to developing a new one. Testing it, if we accept the model, then we're going to reflect on and apply the model and then extend it. And that might even lead us back to developing a new model. The three main stages: given a real-world problem, develop and fit the model, test and reflect upon the model, and use the model to analyze and interpret data to make predictions. So let's get going. We're going to be doing linear functions and models in this unit. So first we have to develop our model. In step one, we have to dissect our problem. We need to know what our two variables are. What are we talking about in the problem? What are we going to be comparing? And so let's look at the data that is given to us. We have the time, t in minutes, and we have 2, 4, 9. We have the amount of water, W in liters, 1,900, 1,800, 1,500. So as we see, time is increasing and the amount of water is decreasing. That definitely is a real world problem. I have well water, and when we are in drought conditions, I am sure the amount of water in my well goes down over time. So what are our two variables? Time and amount of water. Time and amount of water. Which one controls the situation? In this instance, it's going to be time, as time is increasing. So that is going to be our independent variable, which we're going to be labeling as L1 in our calculator. It's also going to be our x-axis when we graph it. And so we can put down, now it says time t in minutes, so we could use the variable t to represent this. We could also use the variable x. Many people like to use the variable x. And it's also going to be L1 in our graphing calculator. Now remember, I say mathematicians love to identify the same concept with many different names, different variables, and so we're just going to have to hold on for this ride of what variable are we talking about, but you have to know that L1 is going to represent our x variable, and in this instant it is our t. The amount of water is going to be our dependent variable, the amount of waters in liters. In the graphing calculator, this is going to be identified as L2. This is also going to be our y-axis. The numbers will be labeled on our y-axis. And this can be identified as y. In this instance, it's going to be identified as w. And in other cases, when we start talking about functions, this will be identified as f of x, or in this case, it could be identified as w of t. So, wow, 5 different ways of just saying amount of water, of representing amount of water. We are going to be really focusing on having the time be L1, having the amount of water be L2, and I'm going to be using T and W along the way. It'll make the transfer of understanding what W of T is when we get into identifying the parts of the function of this model. Okay. So, step 2, after we have identified our variables, we need to graph it on our graphing calculator. And so we have been practicing this. I'm not going to go, well, I can actually go through it quickly step by step. And so we can do that right now. So the first thing that we have to do in our graphing calculator is going to be entering our data. And the data that we're talking about is going to be coming from this table right here. And please remember, L1 is our time because it is our control variable, our independent variable. And so L2 is the amount of water. So now to enter data, we have to press the statistics key. Here's the statistics key right here. The statistics key means statistics. And so to enter your statistics, you push the stat button. And then it says edit. And so even if you're using the Calculate 84 or the Webbit MU app, you do have a stat button, and you will have this menu pop up where it does say edit. So you're going to press 1 for edit, and you see I have some information in there. So we need to clear data from a list. To clear data, you highlight L1. Now by highlighting, I mean you'll put that little black box on L1, and you're going to press the clear button. The clear button is right here. So we press clear. Notice nothing happens, but we just press the down arrow key, and then it clears out. If you do have the graphing calculator apps in your cell phone, the Calculate 84 or the Webbit MU, it's going to have you press the DEL button, the delete button, and you can write that on here, DEL for delete. So if you press the delete button in those apps on your phone, it just will delete it automatically one by one. So now that we're ready to go, what we have to do is we have to enter list 1. Remember, list 1 was the amount of time. So when I enter this, all I'm doing is I'm pressing the number, and then I'm pressing the enter button, which is down here. So I'll do it again. Now L2 is going to be our amount of water. The first amount was 1900, and I just simply press the enter. This is what's called entering data. It's literally putting the data in and then pressing the enter button. And then the last one was 1500. We are now ready to go to make a scatter plot, and those are these set of directions over here. So the first thing, stat, edit, enter data to L1, L2. We have done that. Now we have to set up our stat plot. And so that is setting up your stat plot is going to be this part right here. Basically, when you do that part, it's going to be set for you for the future. So you don't really have to do this every time. So let's do that. So what we have to do is we have to press second y equals. And let me show you what second y equals is. So this stat plot right here, we need to plot our statistics. So we need to get to this button that's called stat plot. We don't want the y equals, we want the blue letters. Now to get to the blue keys, which are the blue letters, we need to get to these secondary keys. That's the blue keys. So all of these blue words here are secondary keys. To get to the secondary keys, you have to press the second button. So we now have to press the second. You'll see this little arrow pop up in the regular calculators, the handheld ones. Your second button in your phone apps will probably light up red or some color that you pushed them. So now we're ready to go. So now, because we have that arrow or it's color, or the second button is colored, we can now get to our secondary keys. So we can press that y equals, and our stat plots are on. Your menu might look a little bit different on your phone. It might just say plot 1, plot 2 on top. That's okay. We just want to make sure that plot 1 is going to be turned on. So let's go through and set this up together as if mine wasn't. So we're going to press enter. Now yours might look like this where it's automatically off. We need it on so we can actually graph. So what you do is you just push the over arrow and you highlight on. I'm right here at this step, highlight on. And after you highlight on, you actually have to tell the graphing calculator that you want that done. So you're going to press the enter button. Now your graphing calculator is on. Once it's on, it's going to be set on until you reset it. So it's pretty much good to go. This first graph right here, that is your scatter plot graph. I just say down arrow to type, highlight first graph, and that is the first graph that's entered. You can press enter, that's fine. And then down arrow to X list. All of these steps here just ensuring that your X list is set to L1. So your menu should always look like this. X list is L1, Y list is L2. If it's not, I just ask you to press the second key and then the 1. What does that mean? Do you see that blue L1? In order to get to that secondary key, remember you have to press your second key and then you can get to your secondary. But if it looks like this, if you go to your plot 1 and it's on and all of these are set, you don't have to do it again. You're set for until your calculator somehow resets, which we hope it doesn't. So as long as that screen looks like that, you're good to go. You're good to go to drop down to these 2 steps, which you always have to do. You always have to do these because you always want your data to zoom in to your statistics. So what we have to do is we have to press the zoom key, which is this middle key right here. You press zoom. And then if you notice in your menu, you have number 9, zoom stat. That means that you want to zoom into your statistics. So you don't have to scroll down. You can just simply push the number 9. And what you get is a nice overall pattern. And so you'll notice here's our 3 points. If we connected these points with a line, we would have a line. We'd have a straight line, so it would just be a straight line, and it would be decreasing because over time, which is our x, our water is decreasing. Now let's say if you wanted to know the exact location of a point, and this is just extending it, you can press what's called the trace key. The trace key is right here next to the zoom key, and when I press that, you'll notice in my graphing calculator, it's blinking on this point, and it tells you that this is where x is 2 and the y value is 1900. And if you just press your over arrow key, you can get whatever points you need. I'm just pressing my right and left key because that's how we read the graph, left to right. So we can just press those left and right keys, and there you go. So now we have the overall pattern of a graph. We can clearly see that this is linear, so now we're going to be making a linear model, which means we're going to be moving on to making an equation. Okay, so let's just answer some graphs. Let's just answer some questions on the graph. So it's a graph the data below and answer the questions. I put the answers in because I did have you do this for class. So if you want to pause and do it and then come back for the answers, you're more than welcome to, but I'm going to run through them right now. Number 1, what can you say about the position of the points? Well, if we look, the positions of the points form a straight line if we connected them. Does the amount of water look like an arithmetic or geometric sequence, and why? It's an arithmetic sequence. We have a constant rate of change. The water is decreasing by 300 liters every 5 minutes, which means the rate of change is 60 liters per minute. We're losing 60 liters. And what I did to figure that out is what I just went from I just went from, my dog is barking. This is actually 19 to 1800 and then 4 to 9. So what I did is I just went, okay, we're decreasing by 5 here, and we're increasing by 5 here, and we're decreasing by 300 here. This is 2 here, and this is 1 here. 100 here. All right. Do you think the linear model, I'm jumping ahead. So 300 every 5 minutes, so I just went 300 over 5, and that is going to give us 60. Do you think a linear model or an exponential model would fit best, and why? So I said linear model because we have a straight line pattern with a constant rate of change. And so once we have that, we are going to see that we need to fit a linear model. What do you think the model will help us do? It's going to help us to analyze data, interpret data, and make predictions. Step 3, let's find an equation for our model. I hope that you saw the amount of water increasing at a constant rate, then lending itself to a linear model. So our linear equation is f of x equals mx plus c, where m is going to be the slope rate of change and c is going to be our y-intercept. Now this is very similar to y equals mx plus b. This is what we usually see in school, 9th grade. You have seen this in Algebra 1, and you've seen this in Algebra 1, 8th grade as well. Now for the IB world, they say we're going to make this a function. So they, instead of writing y, they're going to say we're going to write this as a function of x. And I'm going to review function in 1 second. Equals, same thing, m is going to be slope. Here's your x variable. And then instead of saying b, they use the letter c to represent y-intercept. And remember, y-intercept is where the graph crosses the y-axis. So f of x means function of x. We can also exchange f of x for y, just as I did here. Function. What is the definition of a function? Each input has one and only one output. From our example below, input is time and output is water. So x, f of x. We input 2 minutes and we get out 1900 liters. We input 4 minutes and we get out 1800 liters. We input 9 minutes and we get out 1500 liters. So this is going to be our input and this is going to be our output. We put in, we get out. Okay. So let's see what we have here. So we're using the graphing, We're using the graphing calculator to find the equation. Here are our steps to find the equation. Here are our steps to writing the equation. So let's go through. We're going to now make an equation in the form f of x equals mx plus c. So first we're going to be using this side. This side is called linear regression. Linear regression helps us to fit a model, helps us to fit an equation of a line to these points. So the first thing that I didn't mean to turn it off. The first thing that we're going to do is we are going to push the stat button. This stat button is our statistics button. That helps us to input data, that helps us to get a model. So let's push the stat button. Next is to push edit and then enter our data into L1 and L2. We have our data in there because we just made a graph. Yay! Now let's go back to push stat because we're going to need to now calculate our line. So we're going to push stat and then we're going to right arrow over to calc. Just as I said, calculate. So let's calculate. We need a linear line. So you need to look down to number 4. Now in the graphing calculator, instead of having mx plus b or mx plus c, our graphing calculator world, remember mathematicians like to take the same concept and have it written a few different ways. It's number 4, linear regression. This means that you want to form our model using linear equation, ax plus b. The a is still the slope, the b is still the y-intercept. So we're going to just press 4 and this menu comes up. Now this menu is just our wizard, our stat wizard. So if this menu comes up, you have to make sure that the X list is L1, the Y list is L2, and you're good to go. Everything else should be blank, and you can simply press calculate. Now some people might not have that stat wizard. So if you don't have that stat wizard, and I'm just turning it off right now for those people who don't have it. Okay. If you don't have the stat wizard, it looks like this. And so these steps right here are to actually put those L1 and L2 in. So you have to tell it what lists you want. So you can press second 1. Remember, that gets you to the secondary L1 key. Then you have to push comma second 2. Remember, the second gets you to that L2. Remember that L2 is that second blue button. And once you have that, you can press enter and you will come up with your A and your B. We need those A and we need the B. So here we go. For these steps, some of you might have Stat Wizard on. Just make sure this is set. X list L1 and Y list L2. Then go down to calculate and press enter. For those of you who don't have Stat Wizard, here's what you put in. Now we have to write the equation. Here we have f of x equals mx plus c. We have to substitute our a and our b into the equation. So our slope is m, which is going to be our a number. Our y-intercept is c, which is going to be our b number. So let's write our equation. Our equation is going to be f of x equals, let's look to see what our a number is, negative 57.69. I'm going to round that to negative 57.7. Negative 57.7 x. Let's look at our b number. B is positive 2021.79. I'm going to say plus, since it's positive, 2021.8. And rounding to the nearest tenth is fine. So here's our equation. We can also write our equation. Remember, let's go back to here. And I said we can also do W of t, and we can also call this t. Remember, we can name this a few different things. So instead of calling it x and f of x, we can call it t and w of t. So putting it in terms of the problem, we can exchange this for w of t equals negative 57.7x plus 2021.8. Both of these are correct. Oops, I'm sorry. You got me. This should be t. That should be t. Both of these are correct. This just puts it in terms of w for water and t for time. This is the generic equation where we can use x and f of x for anything. We'd have to say, x is water and f of x is going to be our, x is time, and f of x is going to be amount of water. So either one is correct. Now let's look back, because what I did back here is I made a general statement. I said that our water is decreasing by 300 liters every 5 minutes. So I just did 300 divided by 5 is 60. And that's because I looked at these last two and I said, okay, this is 300 and this is 5. And that's where I got up with this. However, you might have noticed, if you were paying really close attention, that this is 2 and this is 100. So if I divided 100 by 2, I actually get 50 and not 60. So it doesn't seem like there's a perfect constant rate of change here, but that's not true. There is a constant rate of change, and it's actually negative 57.7, which means decreasing by negative 57.7 liters per minute. So water is decreasing by 57.7 liters per minute. So that's what that number represented. So I was just making an estimate of my slope when I was answering these graph questions. I was making an estimate. It did fall between 50 and 60, which is fine. Don't forget that this negative sign, that's my word decreasing. So just be careful, because if you say decreasing by negative, that's wrong. You either use the decreasing word or you use the negative symbol. This number right here is my y-intercept. This is my start amount. So I started with 2,021.8 liters in my tank, or wherever we started with that 2,000. So here is my slope, and here is my y-intercept. And that's how you write the equation, the generic one, the one that fits the problem. This is what my slope means, and this is what my y-intercept represents. You might want to pause here just to kind of take this all in. Okay, let's use our model to make predictions. We're making the predictions. Let's say we want to predict how much water was left after 3 minutes. We're going to use our equation, and because our 3 is our x, which is also our t, you could also say that t is 3 because it is right here. So we can call this x, we can say that this is t. So because x is the amount of minutes, we're going to substitute our 3 in for our x. So here's our generic equation that I used. That was fine. In place of the x, I'm going to put 3. And so in place of this x, I'm going to put 3 as well. So this is going to be negative 57.7 times 3 plus 2021.8. And when you do that on your calculator, negative 57.7, remember that negative button is all the way down here, times 3, I like to use my parentheses as my multiplication, plus 2021.8, we're going to get 1,848.7 liters. So there are 1,848.7 liters of water left after 3 minutes. Love my complete sentence. Does this fit with the data? Well, let's see. Here's my minutes. So my 3 would be right in between my 2 and my 4, which means my answer, 1848.7, would be fitting in between 1900 and 1800. Well, 1848.7 does fit in between these two numbers. My number 3 does fit in between these. So yes, it fits. And that's what I really mean by does it really fit? Yes, it really fits. This is called interpolation. Predicting inside the range of the data is interpolation. Interpolation. Try to say that 3 times. Okay, now let's try. Calculate how much water is in the tank after 15 minutes. So let's do f of 15 because I want to replace my x with 15 because that's the minutes. Negative 57.7 times 3 plus 2021.8. So let's do negative 57.7 times 15 plus 2021.8. I get 1,156.3. So when I put in my 15, I get out 1,156.3. So we have 1156.3 liters left after 15 minutes. Do you think your answer fits in with the rest of the data? Well, let's just go back to our data, our little data chart from the previous question. All right, so we have 2, 4, make it a little bit easier, 2, 3, 4, 9. Now we're dealing with 15. 15 is outside the range of my data. And I got the answer 1156.3. Well, going to 15, this does decrease. This is 1,115.6, which is less than 1,500. So right now I'm going to say yes, it fits in with my data. It's pretty reasonable to say that it's going to be going down to 1,156. Yes. Is less than 1,500. And I'm going to put it is reasonable. Because sometimes we might not get reasonable answers, and I'm wondering what those look like. So this is called predicting outside the range of the data, which is extrapolation. So we have interpolation and extrapolation. So extrapolation, notice that stopped at 9, so it's kind of a mystery what happens out here. So we're predicting outside. Inside the data was here. We were inside that data, now that we're outside. So that's extrapolation. Okay, and our last one for today, video went a little long. Interpolation versus extrapolation. Is it reasonable to use your model to estimate the amount of water in the tank left after 40 minutes? Let's calculate it and then take a look. So you can make a guess. I'm thinking 40 minutes, that's a long time. I'm wondering if it's actually going to run out. That's where my mathematical thought went. So we're going to substitute 40 into our equation. And let's see what we get. So we're going to do negative 57.7 times 40 plus 2021.8. Negative 286.2. Negative 286.2. So to have a negative 286.2 liters after 40 minutes is not reasonable. And the reason why it's not reasonable is, you guessed it, if we run out of water, that's it. It's at 0. So to go below 0 is not reasonable. I'm going to put at 0 liters, we have none. No water. So to have negative 286.2 liters after 40 minutes is not reasonable. We can't have a negative amount of water. At 0 liters, we have none. So we can't even keep going. So let's determine which is more reliable, interpolation or extrapolation. And I'm definitely going to think interpolation, predicting inside the range of our data, because then we can clearly see, is it reasonable? Does it go along with the pattern of our data? Follows pattern. Extrapolation is difficult because at 15 minutes, it could make sense. Here we have our 15 minutes, but then when we went too far outside of our data at 40, it was not reasonable. So this has been building a model, a linear model, touching upon function notation and remembering what our function definition is, making that model, using it to make predictions, and then really testing it out with interpolation and extrapolation. If you need to review this, please go back. I'm hoping this helps everybody. Have a wonderful day. Thank you.